Good evening. It's Mr. Tancow. Yeah, so today, tonight or whatever it is, we're doing angle of inclination. So I thought maybe you should write these notes down. So the angle of inclination, they're saying it's an angle formed between a line, so line AB and the horizontal line. So our horizontal line now is being represented by what? Our x-axis, right? Okay. Uh, in what? In an anti-clockwise direction. Anti-clockwise direction. And you all know how does our whatever tick on your watch rotate, right? So anti-clockwise. Anti-clockwise. So which means our angle of inclination, it's a angle between what? Our line and our horizontal line. You can see that, eh? Any line and the horizontal. So the angle of inclination here it is in a anti-clockwise direction. So most of the time they call it theta, ne? They represent it by what? Theta. Okay. So this is the angle. It's an angle between what? Our AB and the horizontal line. So you can also construct sometimes a horizontal line which is parallel to what? Our x-axis, right? I can also construct another horizontal line here, not on the x-axis, but it's parallel to what? To my x-axis. And then I think we all agree, remember in grade 9 or grade 8 or whatever it is, parallel lines. So if we're having parallel lines, which means these angles are what? Are corresponding. Can you see that? So these angles are what? Are equal. Which means this angle here is the angle for what? Of inclination of AB and this horizontal line. Which means here is what? This theta again. You can say these are corresponding angles. Same applies that the angle between our horizontal line and our line AB, this angle is the angle of inclination of what? Of AB. Can you see that? So we can also call it what? Theta, because these angles are what? Are equal, corresponding angles, because we're having what? Parallel lines, right? Okay? So let's do this thing now. Our formula that we use to find the angle of inclination. So let's just draw a line that passes through our origin. I'll just show you some. Let's say we are having point A, which is x is to y. Then we are having point B. I won't give the coordinates, right? So we know the origin 0 is to 0. Okay, so I'll just put a line here, a point here, point R, whereby the distance from here to here is the same as the distance, is the same x value. The x value of A and R are the same. So here's also what? X. So I'll join this line. Then I'll say the angle of inclination of line AB is what? Is theta. Right? Okay? So we all agree that from 0 to R, from our origin to R, the only thing that changes is x. Y is not changing. So which means we only subtract the difference of our x value. So it will be x minus 0. AR, the only thing that changes is what? It's y. The x value doesn't change, it's constant. So we say it's y minus 0. So if you're having your opposite in the adjacent of theta, we can use our trig ratio. TOA. Remember TOA. Soccer TOA. Soccer TOA. So we'll use this one. TOA. Opposite over what? Adjacent. So you all agree that tan theta will be what? Will be y minus 0 over x minus 0. Opposite over adjacent. So you can see this thing, it's like we're calculating our gradient. You can see changing y over changing x. So which means this thing is the same as gradient. Therefore we say tan theta is equals to what? Our gradient. So this is the formula that we use always to calculate what? Our angle of inclination. Then now I'll tell you, if the gradient is positive, what you do. If the gradient is negative, what do you do? Thank you. Okay, it's still recording. Can we continue? Let's continue. I thought maybe it's the pillow recorder. Let's continue then. So now let's say our gradient is positive. When our gradient is positive. So when our gradient is positive, I'll give a gradient as 1. Yeah? Let's say the gradient of this line is 1. Then we are required to calculate what? Angle x. Yeah? Calculate that x. Is it angle x or x? Okay. So now, because we are given the gradient of this line, and then this x is the angle between our horizontal line, which is our x-axis, and the line that we're having a gradient upon. So, which means x is the angle of inclination. So, which formula do I use? So now, because x is no longer theta, I'll say what? Tan x is equals to the gradient. Then my tan x is equals to what? 1. How do you find our x? We don't divide by tan. So I'll say what? X is equals to tan inverse of 1. Then my x is equals to 45 degrees. So what does it tell us? If the gradient is positive, which means this angle will be what? An acute angle. Okay. So that's how we find what? The value of x. Are we together, right? Okay. So now let's check if our gradient is negative. How do you do it? So now we are having a negative slope, okay? Our gradient is less than 0. So let's say we're given the gradient of this line is equal to negative 2. Then we are required to find what? This beta. Okay? So we can all see that this angle, it's more than 90, but less than 180. So according to our, is it grade 7 or grade 4? Somewhere up. We're told this angle, what is the name of that angle, guys? It's an obtuse angle. Obtuse. Obtuse angle. So which means the angle that you should get, it must be what? More than 90 but less than 180. So if you don't get that, which means you did a mistake somewhere. Eh? Alright, so let's go to our formula. We're having a gradient, then now we're dealing with beta. So I'll say tan beta is equals to the gradient. Then my tan beta is equals to what? Negative 2 as the gradient. Then I'll say what? Beta is equals to tan inverse into negative 2. Then I go to my calculator, I'll say what? Tan inverse of negative 2